So what
So can you
exactly?
scroll?
Yes.
So can you scroll up little?
Finished.
Yes, sir. Yes, sir. Then.
Okay. So what exactly we are having this concept called domain name system. Uh, it is basically used for name resolution purposes. Okay, name resolution. Okay, purpose is used. Name resolution means when we are converting the names to IP addresses or IP address to names. Okay, so name to IP address and IP address to name resolution. This is what exactly is getting used over here in this entire concept. Okay, simply it means that when you are visiting any website, okay, most of the time we are basically typing the website address like this, right? Yes or no? We're simply just typing the address like https www.google.com, or sometimes we simply just type google.com like that, and we are getting the web page of Google, right? Yes or not? From your system, when you are typing just google.com, you are getting the Google page, right?
Yes, sir. Yes, sir.
Yes. So how exactly you are getting the Google page? Okay, because all these machines, what exactly we are having in our network, they are having the names, right? They are having a name. As you can see that we have a www server name. And this is IP address, right? What
Yes,
this
sir.
machine is having.
Yes,
Yes or
sir.
no?
Yes,
So,
sir.
so when you have a name of the machine and you have an IP address of the machine, simply you are just typing the name of the machine, right, over here. This www, it
Yes,
is
sir.
the name of the server in Google, right?
Yes, sir.
So you were simply just typing the name and you were accessing it. Okay, but your system is not using this name. It is using which address?
IP address.
IP address to access this server. Okay, so when you are typing your name, what exactly is happening is your name is getting converted to an IP address. Okay, so this is the IP address what your system is using to communicate to the Google server 150.160.70.1. Okay, this is the IP address what your machine is using. You are using the name, but your system is using the IP address of this particular server machine to access it. Okay, because always it is the IP address by which we are communicating, we are accessing informations. Always it is IP address and not the names. Now the question is how to find out this IP address of this server machine, which is located in Google. Okay, this is a web server, everyone. www, it basically stands for World Wide Web. Okay, and every single like what company they're having a web server available, whether it's Facebook or Yahoo or Instagram or Twitter or like what Google itself. Every single companies they have a web server, and this is the like what IP address of these servers what you are having. Okay, because to make communication on in a network environment, always you require an IP address. The question is how to find out what is the IP address of this machine called www in Google. So this is when exactly this particular chart is coming, everyone. Okay, so always we are having a root domain. Okay, this is a root domain which is always represented by dot. Okay, this is a dot from which exactly all this particular thing starts in DNS. This is the main starting point. Okay, so you have a root domain server available which contains informations about the top level domain servers. These are top level domain servers like edu, com, gov, org. All these are top level domains. Okay, what we are having. So all these like what top level domains, it simply indicates the purpose. Okay, what is the purpose of these companies to create these domains? Okay, like Google domain, always you can see google.com is there, but com is representing what? That is commercial. Google is doing business, right? They're a company, and these companies are providing their services to customers. All these are basically coming in commercial business. This is why exactly this domain is used. Okay, this is for educational purpose. Any, if you want to create your domain, okay, this is when exactly you are using the .edu domain. Okay, if you are a government related organization, then you will be seeing that this gov is there, okay, in the domain. It is totally depending on what is the main purpose of your business. This domains simply just indicates that. Okay, so what type of websites you are trying to create? It is like what educational purpose website, or like commercial related purpose, or government related, or non-profit organizations like charitable organizations, like what related websites. What type of websites we're creating? This particular top level domain, it always like what clarifies that. Okay. Now, since you can see that we are having com over here, and after that Google is coming. So from com, this Google domain is coming. This are basically called second level domains. Okay, the second level domains always are created based on the company names. Okay, you are having Yahoo, Google, all these are companies, and the name of the company is always are used to create the second level domains. Okay, let's say that you are also having a company and you want to create a website for your organization, then you will be creating it in the com domain because that is commercial purpose you are using it. Okay. So this, all these second level domains always like what is created using the name of the company itself, like facebook.com, ibm.com, hp.com, cisco.com, like that. You are having all these companies names are coming in the second level. Okay, so over here you are having google.com. Now from Google, you can see that we are having this particular server, which is www. Okay, this www basically is the name of the machine what Google is having. Okay, similarly Yahoo also is having their web server www. Similarly Facebook is also having their US server, okay, www. All this particular type of web servers are there in every single companies. Okay, and all their names and IP address information always are stored in this particular second level domain server. Okay, what we are having, the authoritative name server. Okay, the authoritative name server is that server, okay, in DNS, which contains informations about all these machines, name and their IP addresses. What exactly we call it DNS records. Okay. These records are nothing, but what is the name of the server? www. What is the name of this? What is the IP address of this server? 150.160.70.1. These informations, the name and IP address informations of these machines, it is basically stored in terms of records in this database on this server. Okay, this is called authoritative name server. Okay, so this authoritative name server is nothing but the server who is holding that informations, whose database is stored with all this name and IP addressing informations of these machines of Google. This is what we are calling as authoritative name server. So all these are like what DNS database information always is contained within this authoritative name server. So what, when you send a request, okay, when you are sending a request, this is a request coming in. It is DNS request from your machine. It is coming in to the root over here. Then from here it is coming to the com. Okay, so this is the com domain, and from com it is Google. So from over here it is the Google domain it is coming in. Now when this request is coming on to the second level domain, this is the authoritative name server, which basically has this informations of this www. Okay, the IP address. This one is sending the reply. Okay, so the reply is coming in this way. This is 150.160.70.1, and this is what we are getting the DNS reply from this authoritative name server of Google. Okay, and this reply is given to this machine, and when this machine has got this IP address, this is when exactly it is using this IP address to communicate. So it is simply just using the IP address over here like this. Okay, so it is using this IP address in this manner, and it is communicating to this server like this. Okay, so Name always is convenient for us as humans to understand it, to remember it properly. But when it comes to communication between machines, this is when exactly uh, it is IP address. What exactly is used? Okay, without IP address, we cannot make communication. But how do I find out these IP addresses? Okay, how my system will what we figure out what exactly is the name. Okay, what is the IP address of that particular name what we are trying to access. This is when this name servers always is giving you the response. Okay, it is giving you the replies, it is giving you that information that what exactly is the IP address of this machine named www. Okay, so all these machines, okay, that full address, it is called FQDN, fully qualified domain name. For example, if I want to access from this system, if I want to access this PC0 of Google, then you can see that Google is having this department called sales department. And in the sales department, we have this machine coming in. And the name of the machine is PC0 over here. So if I want to access this machine with the full name, then it becomes pc0.sales.google.com. This is what you are having, the root. Okay. So always it is processed in the reverse order. Okay, you can see that. When we are typing it, at the time we are typing pc0.sales.google.com. But when the DNS is processing it to give you the IP address of this machine, then it is processing from this from the reverse direction. Okay, like it is starting from dot. It is your root domain, then the top level domain, then second level domain, then you are having another subdomain coming from Google, then you are having this machine. This is what exactly you are having the DNS, how it is processing your requests to find out this machine's IP address. Okay, this is what we are calling as FQDN. Okay, when you are including the name of the machine which you want to access, okay, in the entire top level domain, second level domain, everything you are including it, the full name is called fully qualified domain name. Okay, similarly, if I simply just show you this. So let me just open the browser, everyone. Just hold on. So this is the browser is opening right now. Just hold on, everyone. It's taking a little bit time. Okay, so here exactly, if you simply just type www.google.com. Okay, now this is what we are calling as FQDN, because here I am mentioning the name of the machine which I'm trying to access in this particular second level domain, in this top level domain. Okay, so it simply works. If I simply just give enter, you can see that it is giving me the web page of Google. This is a web server of Google who is giving me this page. Now, the same thing, if I type it without mentioning the name of the server, just I'm typing the second level domain and the top level domain name, then also you can see that I'm accessing the same page. See that in both cases, when I'm mentioning www over here, that is also I'm getting the same page. And when I'm not mentioning this www, this one also I'm getting the same page. Okay, so it clearly indicates that like what, whether you are accessing from second level domain, you are also getting the same page. And if you like what mention specifically the server name over here, this one also you are getting the same page. Okay, but this one is called FQDN. Okay, we always call it FQDN because over here you get the full name of the machine which you are accessing in this second level domain, in this top level domain. Okay, but if I simply just give it like this google.com, then we cannot call it FQDN because it lacks the name of the machine. We're simply just giving the second level domain and the top level domain without mentioning that which machine we want to access from this second level domain, because we have lots of machines. Okay, but it is always assumed that when you are typing the second level domain directly along with top level domain, it is always assumed that you are accessing this web server. This is a web page, because this type of pages are provided by web servers only. Okay, you are not getting any like what any other like what services offered by the web server apart from this. These are the type of web pages. Always we are getting it when we are having web servers available in our network. Okay. Now, one thing I would like to show you that in all these cases, we are not typing the dot. This over here, this dot we are not typing. Okay. But still we are seeing this particular response is coming, this page is getting displayed. What exactly if I type dot after this com over here like this? So here I'm mentioning the root of the domain, that is dot. Okay, over here if you see, this is the starting point, this is the dot, then we are having com, then we have Google, and lastly we have www. Okay, so if I simply just enter this, you will see that we are getting the same page without any problem. This is the same page because DNS is processed from the root. Okay, always it is processed from this dot over here, then it will come to top level, then it will come to second level, and lastly it will get this particular machine's IP address. Okay, this is what is going on, everyone. Okay, just think of this particular diagram, a tree. Okay, a tree like structure. A tree, the way it is connected to the ground, okay, its roots, and it is having so many branches coming out of it. Then from one branch you are having several sub branches coming out of it. This is just a hierarchy. It is the architecture what we are having used in order to resolve names to IP address to names. Most of the time, it is the name to IP address we are doing the resolution. Okay, with this particular DNS concept. So whenever you are visiting any website, simply you are just typing the name of the website rather than typing the IP address of that particular machine which you are accessing. Okay, so how exactly to find out these addresses? This is your DNS which is doing that. So it means it happens very fast. Okay, it happens very fast in the background. Okay, it is always happening, and we are getting this type of pages in response. Okay, so using names also you are accessing your web pages. Okay, you are accessing your machines, provided that you have records available in it. Okay, in the DNS database of the servers, because if you don't have these informations available in the database, then these informations over here like this IP address, this machine will never get it. Okay, because all these machines, okay, IP addresses are getting stored over here along with names. So if this authoritative name server doesn't have any information about this machine's IP address and the name, then obviously this request, okay, it cannot be resolved. And that is why exactly always it is important to manage this type of servers with server configuration. So we have DNS server configuration available in the advanced module, okay, in the server technologies. So like, but when you will be doing the advanced module, at the time you will come to know that how you are going to configure this type of records in this DNS servers. Okay, but it's always about the authoritative name server, who is performing the name resolution ultimately for this type of machines, which is available in a particular company. Okay, this is your name resolution process, everyone. Okay, the very simple thing, okay, the very simple way to understand this is when you are accessing any machine, is when you need an IP address, you need to know the IP address. But since we don't know it, this is the DNS server, which is basically doing that resolution for us. Okay, it is finding out the IP address of the machine which we are trying to access using just the names. Okay, the names and the IP address are stored in the DNS server, and these informations are basically given to you, okay, when you are sending the request. But like what only the authoritative name server can give that information. This server cannot give it because this server is having that a particular IP address. Only your DNS server is providing that information to you. Okay, so this is your like what DNS, everyone understood?
Sir, where this DNS server used to present?
Like what, in the company you are getting it, you are making it, right? When you are doing the DNS server configuration, then like what, you will be doing all the records, all this database, you will be maintaining it. Okay, but normally in the ISP, okay, if you are taking an internet connection, then ISP is already having a DNS server available, and they will give that IP address. Like for example, in DHCP, you have seen that, right? Over
Yes,
here, we are getting a DHCP. We're getting a
IP
DNS
address we are
server
getting.
configuration, right? This is 100.2 over here.
Yeah.
Like what, when your ISP will be giving you the internet connection, at the time, like what, they will give you the DNS server address. So whatever name resolution you want, okay, your DNS server, okay, your ISP DNS server will provide that name resolution. Okay, so any more questions? Tell me. This is, you are having some notes, which is basically available in DNS, everyone. This is your domain naming system. So simply just I have explained this particular concept over here, okay, with the help of these examples. Okay, so which will ultimately help you to understand the concept better. Okay, so that is why exactly I've explained over here with some examples all these particular concepts like TLD, authoritative name server, DNS recursor, all these things. So simply just take the screenshot and go through all these things. Okay, all this what we have explained. Okay, from the last couple of minutes. Okay, this is what is explained over here in
सर लिख के
very
ले
easy
रहा है क्या?
language. Yes,
लिख
Ganesh,
के
tell me.
लिख के नहीं लेना है क्या? वो
नहीं
स्क्रीनशॉट
नहीं,
लेना है क्या?
स्क्रीनशॉट ले लो, स्क्रीनशॉट ले लो, स्क्रीनशॉट ले लो.
How can we find out the IP address of any such server, sir?
Which one? DNS server.
DNS server, yes, sir.
DNS
For
server
any,
always your ISP will give you, no? When you are taking an internet connection, at the time ISP will provide you the DNS server.
so
When
for
you are
example, I am typing www.google.com. Then how can I know the IP address of that Google server?
your
That is the
ISP,
IP they are using.
yes. See, when exactly you type this google.com, right? Then you are having your ISP. Your ISP DNS server is over here. Okay, so ISP DNS server will receive your request. Okay, now this server, if he knows about this IP address over here, okay, www, at the time it will provide you the IP address. Otherwise, he will communicate the root server. From the root server, it will be communicated to com server. From com server, it will be communicated to Google server, and Google server will provide you the IP address to this, like what, ISP server, and ISP server will provide you these informations.
How can we see that IP address using a CMD?
No, you cannot see that. Okay, this particular IP address, what exactly you are using, right? If you want, you can see that. Okay, but normally when you are browsing, okay, like this type of thing, then you cannot see that. You will be only seeing the name, because on the background, this address is like what it is working. Okay, your system is using the IP address of this server in the background. But if you are using CMD, okay, then you can see that. Okay, from your command line, you can easily see that. Simply just type ping www.google.com. Okay. So can you see this address over here?
Okay, this is the IP address they are
This is the IP
communicating.
address of your www.
Okay.
Okay. So this is your DNS. Okay, this is your DNS request, which is getting resolved using these IP addresses.
Sure, sir.
Okay, because you are using application, right? In the application, these informations are not displayed, but in the background, it is working. Okay, so that is why you are only seeing the name of this over here. You never see the IP address of this server in this URL. Okay, in this address box. So this is what you are having, everyone. Okay, simply take the screenshots. All of you have taken the screenshot,
Yes.
Yes, sir.
right? Okay. This is about your DNS. Okay. So now Tell me what exactly you have understood and what you didn't understand. Yes, Anjali, Anjali is there. Akash,
So in that screenshot,
Yes,
the
sir.
World Wide Web accessible via HTTP port number 80. HTTP has port number 80. www dot does not have a port number. No? Port
this
number 80 is
particular
for
thing,
HTTP.
this www itself is HTTP. In other words, when you say www, right?
Yes, sir.
In other words, it simply means that we are using HTTP, port number 80. Okay. Always www, it is representing port number 80, which is HTTP. And HTTP is using which transport layer protocol? TCP, right?
TCP.
TCP protocol. So this is what you are having. Okay, www always it is representing HTTP protocol and port number 80 only. Okay, this is just a name. It is just a name. The ultimate thing is over here. This is the ultimate thing. HTTP, Hypertext Transfer Protocol. This is a port number used for making communication to the web server. That's it. Okay, so any more questions?
Can you repeat FQDN?
FQDN is the name of the system, the full name. Suppose from this system, you want to access this particular system, which is available in sales department of Google. Okay. So when you were accessing it, at the time you were typing what? In your address bar, you were typing pc0.sales.google.com
.com.
dot, right? Okay. You are always starting from this point. From this point, you are typing, okay, first of all, you were typing this, then you were typing this, then you were typing second level domain and top level domain, and at last you were typing root. Right.
Yes, sir.
This is the way when we are writing the address, okay, in the address bar, always we are typing from the last and we go to the first. Okay. But when your DNS is processing your request to find this machine's IP address, then it is processing from which? From the very last. So this is your dot, right?
Yes, sir.
So from the root, it is coming to top level domain,
Top level
com, then it is
com.
coming
Then
to second
second
level
level
domain,
domain.
then it is coming to subdomain
Sale
of Google,
subdomain.
then it is coming
Sales.
to this particular machine, right?
Yes, sir.
That's it. This is what we are calling FQDN. When
Okay,
you are
sir.
mentioning the name of the device which you want to access from a specific domain, this is what exactly we are calling it FQDN. If you are simply just saying sales.google.com, then in sales you are having lots of other machines also there, no? Yes or no?
Yes, sir.
So which machine you want to access? You have to specify, right?
Yes, sir.
All these machines are part of sales, right?
Yes.
But which
Yes.
machine you want to access? This is when you are specifying it. This is FQDN, fully qualified domain name.
Yes. Okay, sir.
Okay. Any more questions? Okay. So all of you have revised the concepts what we have discussed from the last couple of days. All of you. Have you guys done the revision part properly?
No, sir.
No?
Yes, sir.
Okay. So network devices, can you tell me some differences between the hub device and the switch device? What is the difference? Can anyone tell me the difference between hub and switch?
Hub device sends the complete signal to everyone, while the switch signals send the signals to the specific PC, sir.
Okay. And how exactly it is sending it to a specific PC? How? Yes. how exactly the switch is sending the information to a specific PC?
So they cannot send it to a specific PC. Actually, it broadcasts the message or broadcast the packet that he have to deliver to, and he delivers it to everyone connected to that hub.
No, switch perspective. From the switch perspective, how exactly informations are getting delivered to a single system?
So the hub, the switch raised views at the MAC address provided to him of that PC where it wants to communicate.
Okay, MAC address of the system is used.
Yes,
And where exactly is that MAC addressing information found?
an IC card of the PC.
That is correct. But how come your switch understands that? How come your switch understands that this is the machine to whom I have to send the frame?
Machine requests actually three-way handshake.
No,
We use
no,
IP
no,
address to send the data to
no,
specific.
no. When you were talking
What?
about switches,
What?
switches always understands what? MAC
Connected.
information, right?
What information, sir?
MAC addressing information, right?
MAC address. Yes, sir.
So the question is that how come a switch understands that this is the machine to whom I should send this frame?
Because the sender machine tells him to send where to send that data actually.
Sender machine
Sender,
tells
sender machine sends the destination where it wants to send, but maybe don't know, sir.
okay, who can tell me? Who can tell me the basic functionality of a switch? Tell me. Okay, so it will basically create a table, and the table name is called what?
MAC table.
MAC table. Another name is also there, no?
Yes, sir. CAM table.
What is the full form of it?
Uh,
The full form of CAM,
Content addressable memory.
content addressable memory, right? Now, what this particular table it contains?
MAC
Will
address of
contain
all the
the
devices.
port number and the MAC address.
Okay, port number and MAC address. Now tell me that using this MAC table, how a switch forwards a frame?
I think it.
I'm giving you a situation right now over here. Tell me this. You have your system, okay? This is your system. This is my system, okay? Both these systems are connected via a switch device. This is your switch device. And we are connecting both the systems over here. Okay. Now this is the port which is connecting 0/0 and 0/1 over here. And this is the port number FA0/2 over here. Okay. So these are the port numbers. What is connected to this machine? Now this is your MAC address. Let's say you have uh, ABCD.1111.2323. This is the MAC address of this machine, and let's say ABC1.4455.916. Okay, these are the two MAC addresses of the systems. Now I'm giving you a situation in which you will have to tell me that if this machine is sending a packet, this is the packet. Basically, we call it frame. At layer 2 level, we are always calling it frame. If this frame is for for left 2, if this frame is for left 2, if it is sent to this particular switch, okay, then how exactly this frame is getting delivered to this particular machine? Are you understanding the situation?
Yes. Yes. Actually, basically, this frame will contain the sender and the destination MAC address.
Okay, so frame will contain the sender and the
Destination MAC address.
receiver MAC address, right? Okay. So using that information, how this frame will be forwarded?
In the form of packets.
No, not in the form of packets. We're talking about switches, right? When we talk
No,
about
I
switches,
think,
this is frame.
yeah. I think when this frame will reach the switch, then switch will have that switch will be having this MAC table. So it will find out that this MAC address is attached to which port, and then to that particular port. I think it will forward the frame.
Absolutely correct. Absolutely correct, Bhaskar. This is your MAC table, right?
Yes.
Every single switch, it is having a MAC table, and the MAC table contains the port number and the MAC address
address.
information, right? So when this frame will be coming to the switch, at the time it will be containing the source MAC address, right? Which is this, and the destination MAC address is this, right?
Yes.
So when the switch like what checks the MAC address table, it immediately finds that this is the destination, which is over here in the frame. So which port is assigned to it? This is the port. So immediately it is forwarding the packet or the frame to this particular machine. So this is how exactly we're forwarding, okay, or a switch is forwarding the frame. Very good. Now, can you tell me something about router? What exactly you think of a router?
Router works on a network layer.
Okay.
Like you said yesterday that router is basically used to connect to two different lanes. When if you have to transfer the information from one LAN to another LAN, then you have to use the router.
Okay. So
It maintains a table called routing.
okay, so can you just give me an example of this? An example where exactly I can use a router.
When there are more than two networks.
When there are more than two networks.
Yeah, between two networks, it performs routing, exchange the data.
And what exactly is routing?
Sir?
What is routing actually?
Exchanging of packets.
Exchanging of packets between machines.
Routing means basically it will define the route only, that on which route this frame or packet should flow to reach that particular destination, which is a part of a particular LAN. Router the sole aim of router is to decide the route that packet should follow to reach the destination.
Okay, so let's say, so I'm giving you a scenario. Let's say that you have, this is your LAN, okay, and this is my LAN over here. So let's say that this is my LAN. Okay, so we're having two LANs over here in which we have machines. So in my LAN, I'm having two desktop machines, and in your LAN, you are having some server machines are there. You have laptop machines are there. All these machines you are having it in your LAN. Now you are having a router in the middle, and this is the router which is connecting your LAN to my LAN, right? This is what you were saying, right? Now tell me how exactly this entire communication will be going on. How this router will do that.
It forms a
It's
big
a routing table.
So routing table, with the help of routing table,
Okay.
it performs routing. It maintain a table which is called routing table, and routing table contains information about the destination network and submit mask info or administrative distance info.
next stop IP address.
Yeah,
Next stop
and
IP
metric info,
address.
etc.
Okay.
Yeah. So,
So
It forms a
yeah.
yes, continue.
Yeah, so router is a device which is used to connect multiple LANs together, and it will transfer the data or information to means systems. Means from one system, it will give the information to the router, then router give the information to our systems.
Okay, very good. So this is your router, right? Which is used to
Yeah,
connect multiple LANs and making communication happening between two LANs, right?
yeah, and it is called gateway also.
Gateway also. Very good. Okay, everyone. There is something called topologies. What exactly you need to know? Okay, this is something which is related to network designs. Okay, we call it topologies. What exactly is topology is this type of design. For example, when we have systems, okay, like this type of systems getting connected with this type of devices. Okay, let's say that you are connecting over here from here. Okay, all these machines are getting connected. This entire thing over here. It is called a network design. Okay, the way we are connecting all these machines to these devices for making communication, these are considered as a topology. Okay, topology is simply just the design, the layout of the design what you are having. Okay, this is the type of design what exactly you are having. Okay, when you are designing a network, always you have to decide that how exactly you should be designing your network. Okay, how you should be making your topologies. So topologies we're having like these are the types of topologies like bus topology, star topology, ring topology, mesh topology. Uh, Fifth one is tree topology. Then sixth one is hybrid topology. Okay, these are the six common types of topologies. What exactly we use when we are designing a network like this. This is when exactly we use this type of topologies. Okay, now this example, what you are seeing over here, it is coming from star topology. This one. Okay, you can see that a star type shape over here, where every single device is getting connected with the main device. This is called a centralized device. Okay, and this device is making communication happen. Okay, between all these machines. Any machine can communicate with any of these machines with the help of this device. This is the type of topology what exactly we are having it in the network topologies. Okay. So these are different types of topologies are there. If you want to find out what are the types of topologies, you can simply search on internet. Okay, regarding this, you can get all these informations over here. But for the purpose of this concept, let me just give you some points about the bus, star, ring, mesh, tree, and hybrid topology. Okay, if you simply just open the Google browser over there, if you simply just type the network topologies, this is when you will be getting this bus, star, ring, mesh, all this. Okay, different types of topologies are there. Uh, as you can see. Can you see everyone? Can you
Yes,
see
sir.
this?
Yes, sir.
Okay, this is your bus topology. All this circle, what you were seeing, right? This circle, these are simply representing laptop, desktop machines, server machines, okay,
Systems.
routers.
Systems.
All those are devices which you are connecting on your network. It is simply just representing this. Okay. So as you can see that bus topology, you are having one single cable getting connected to all the systems. Okay, this is the main bus cable what we are using in order to connect all the systems. Okay, this is bus topology. Star topology, you can see this is the star topology. The same way we have designed our topology, right? Is it the
Yes, sir.
same or different?
Same.
It's the same, right? This is your star topology. Okay, over here you are getting it. Okay. Then we are having ring topology, means one device is connected in a ring fashion. Okay, means your system is getting connected to another system, then this system is getting connected to another system. In this ring fashion, you are connecting all the systems and you are doing communication. This is
And
a
there
ring
is
topology.
so there is no switch or
No,
hub
no, no, no.
provided to
Directly you are connecting.
directly
Okay,
device.
from your system to another system, you are directly connecting. This is your ring topology. Then you have tree topology. Can you see this tree topology? It is basically the same type of like what structure what we are having in DNS as well, right?
Yes.
You see, this is the same type of structure. From root, it is coming branches, and branches we're having sub branches coming in. Basically, it works like this. Okay, let me just design one topology for you. If I simply just take some systems, okay, let's say that we're having in this manner. Um, let's say that we have this type of devices like switches. Okay, from this switch we are having all this type of other switches. So we have two switches are there. Okay, then from this switch we are having couple of other switches. Okay, like this, and we are connecting like this. Okay, in this manner we are connecting. So from here connection is going, then from here connection is getting distributed to multiple branches. This is the type of topology what we are calling as what, tree topology, where you are having one root and you are having all these are branches coming out of it. Okay, this is the type of design what you are having in the tree. Okay, then we are having mesh topology. Now mesh topology means what, everyone is connected with everyone. Okay, so you are having all these machines getting connected. You can see that this is your mesh topology. If you have, let's say that three systems. Okay, these three systems, then you have one connection going from here to here, another connection is coming from here to here, then you have another connection coming to here. Okay, if I add one more system over here, okay, every system is connected with everyone. This is what you are having in the mesh topology. Okay, so this system means what, right now we are having how many systems are there? If I want from this system
Three.
to connect to all the systems, then I need to connect to all these three systems, right? So one connection is coming from here to here, another connection is coming from here to here, and another connection is coming from here to here. Yes or no? So
Yes, sir.
can you see that from every single system perspective, you are having all these other systems getting connected, right?
Yes.
Yes or no?
Yes, sir.
From this system perspective, you can see that we have three connections going. Then from this system perspective, you can see that we have three connections going, and from this system perspective, we have three connections which is going. Okay, this is what we call mesh. Means every single device is connected with everyone. Then we are having hybrid. Now hybrid topology simply is nothing but simply just the combination of multiple
Combination of
topologies.
any two.
Okay, so you can see that this is the ring topology, right? Over here we are using it with mesh topology. Okay, you can see that this is a mesh topology. What exactly is getting connected with this ring topology? Okay, this is the type of things what you are having over here. Okay, so hybrid topology is always a combination. of your multiple topologies. Okay, like tree with star, bus with ring, okay, mesh with star, like that. Multiple combinations you are doing it. Okay, which makes it a hybrid topology. So this designs what we are making in the network. Okay, always it is coming from this hybrid star ring mesh. Okay, tree topology only. And in the organization also, you are going to see this type of topologies are being used. Okay, so that is why exactly it is important to know what type of topology is what. Okay, what are the advantages, disadvantages, why we should be using tree topology over star topology, what is the difference between mesh and ring. These informations you can simply just go ahead and check it out. Okay, on these websites there are like what differences and all these things are available. Simply just type network topologies, very easy to understand language, and they have given the informations. Okay, so simply just go ahead and check it out. Okay, this is something which is related to network design, everyone. Okay, when you will be doing the practicals, okay, this is when you will be setting up the network using this design. So this is why you have to know that which particular topology is best, okay, for what type of requirement. So this is the differences, advantages, disadvantages, all of these things you will be getting it. Okay, just type network topologies in the browser and you will be getting it. Clear?
Okay, sir.
Okay, sir. Okay.
Okay, so in the next session, what we are going to be discussing is the remote access file permissions. Okay, remote access file permissions and IPv6. These are the three concepts what we are going to be discussing. Okay, and tomorrow is Saturday, right?
Yes,
Okay,
sir.
so today is Friday, so tomorrow is Saturday. Yes, so tomorrow is going to be the last session, everyone. Okay, and these are the three concepts which is remaining. Okay, we'll cover that in the next session, and that will be the last session of your basic module with me. Okay, so just go through all the things. Okay, what exactly we have discussed. Okay, any questions you are having, simply just ask me in the next session. And similarly, all those notes like screenshots, if you have taken it, that is good. If any one of you haven't taken the screenshots, you can simply just tell me, I'm having time. Okay, right now I can provide you the screenshots. If anyone has missed anything, simply just tell me down. Yes, all of you. No one
Sir,
has missed anything, right?
no.
Yes, Pastor, tell me.
Sir, I have one question, sir.
Go on, tell me.
Sir, I am getting confused in the session in the transport layer. Like in session layer, like you have said that session layer will be taking care of the session establishment, and once the communication will be done, that session will be closed between the two hosts, correct?
That is correct.
Then when we comes to the transport layer, there when we use the TCP protocol, so there our three-way handshake is happening.
Yes.
So there again session is getting established, or how it is different from the that session that is established in the session layer?
First of all, session will be established. Okay, it is like what? See, for example, if you are using, let's say that, if you're using
Suppose
Gmail,
I'm
okay, if you're using
okay.
Gmail, you were
Yes.
sending a mail to someone using Gmail application, then your application, the Gmail application itself is programmed to use TCP to build connections. Okay, because these are applications, right? What you're using, and these are programmed, right? Someone
Yes.
has coded, right? They have
Yes.
done the programming and they have made the application. So when they're developing the application, at the time only they have used TCP. Okay, they programmed it like it. Okay, so that always when you are sending mail, then TCP always will be used. UDP will not be used. So always when applications are developed, this is when exactly either the TCP to use it or UDP to use it. These things are decided. Getting my point?
Okay.
It is not like that you are having the choice. Okay, it is the programmer, okay, the application programmer who is developing that application. He is deciding that what exactly is the best for doing the communication with his application. Okay, and whatever exactly he is deciding here, he's using just only one of them. Either TCP he can use, okay, he can program his application so that, like what, when you are using it, always you are using TCP, okay, to make communication, or UDP to make communication. It totally depends on how
TCP,
exactly they have developed their application, okay,
TCP sir
how they have
provide
programmed it.
Okay,
guaranteed
sir.
reliability, na, sir.
Sir, that is fine. Okay.
Data.
So, like you said, this Gmail example. Suppose I have written down I have opened my Gmail application. Okay, and
Yes.
I'm started drafting the mail. So in session layer, what will happen basically?
Session layer will be creating the session, right? You are interacting with the Gmail server, right? You are interacting with the Gmail server. So how long exactly you were signed in? Okay, for how long you were signed into Gmail server? Okay, how long you were doing your activities on that particular Gmail server? This is the information tracking which is done based on the session information, right?
Okay.
The sign in, sign out, you were doing it, right? This is the creating the session, right? When you were signing in, you were creating the session directly with the server itself. After
Okay.
signing
And
in, you
once
were
I
doing all the work, right? So you were
okay.
maintaining the session over there on the server. And when you were done sending mail, this is when you were signing out, right? This is you are
Okay.
closing the session.
Okay. And then when I click on send button, at that time my transport layer comes into picture, TCP and UDP, correct?
Yes, it is already means what? When you are sending that particular mail, right? Since it is
Yes.
already defined in Gmail, it is already defined to use TCP only. Okay.
Yes.
All these things are already taken care of. Okay, all these things are already like what it is defined that whenever you are sending this particular mail, it will be like what sending it via TCP only. So the connection and all these things are already established. Okay,
Okay.
it is just waiting for you to hit that send button. But behind the scene, everything it is already established by the application itself. Okay, because the
Okay.
programming, they have done the programming in this manner that when you are drafting the mail and all these things, right? All these connections, all these things are getting established, okay, automatically behind the scene. And that is why exactly when you hit the send button, immediately you see the status, right? That message has been sent or not.
Yes.
Yes. Otherwise, if you are sending, if you are hitting the send button, and if at the time when exactly the connection is getting established and all, it will be taking time, right? Yes or
Yes,
no?
sir.
This
Yes,
is
sir.
why
Yes.
exactly all these things are basically established. Okay, when you are drafting the mail, only all these connections are getting established, all these sessions are getting created, and it is just waiting for you to send that informations, okay, via TCP to that destination. Okay, and you are also getting the response message, right? If your mail is not delivered, you are getting an error message, right? The mail not
Yes, sir.
delivered. This type of messages are coming in. This is your acknowledgement, which clearly indicates that TCP is working on the background.
Correct. Okay. Thank you, sir.
Okay. Any more questions?
Sir,
Battery
what is troubleshooting?
troubleshooting. Okay, troubleshooting means what? Okay, you are having. Who is asking? Malad.
Yes, sir.
Okay, you have your smartphone, right?
Yeah, right.
Okay. Okay. So suppose you are saying that your smartphone is not like it is not coming up. Okay, it's not switching on.
Yeah.
What will you do? If your
Come again.
smartphone is not switching on, what will you do?
Mm.
Hmm? What will you do, Malad? Tell me. If
I
your
will try.
smartphone
Mm.
is not switching on for some reason, it was working. Okay, 1 minute ago it was working, but right now you press that unlock button, it's not unlocking. Okay, it's not
Yep.
switching on. So what exactly would you do?
I will try to repair my phone.
You will try to repair your phone. So to repair it, first of all, you have to identify, right? Where exactly you have to repair. Yes or no? What you
Yes.
have to repair, you have to identify. Yes or no?
Yes.
Yes. So this identification of what exactly is the problem and fixing the problem, this is what we call as troubleshooting.
Troubleshooting.
Understood now?
Okay. Understood, sir.
Okay, so this is a real-time example, real environment example. Okay, so in network always we have this type of issues. Okay, someone cannot access internet, someone cannot access certain application from server machine, someone cannot access a particular website, someone cannot access certain services from certain servers. Always this type of issues are there. Okay, this is when exactly we as network engineers, when we are working in the company, this is when we find out where is the issue, which user is facing the issues, and we provide them solutions. Solution means you are fixing them. That's it. This is what we call troubleshooting. Any more questions? Okay, so Pranati is there. Akanksha, Gajanan.
Yes, sir.
Yes, Akanksha.
Yes, sir.
Understood everything.
Sir.
Akanksha.
Yes, sir.
Any
Yes, sir.
questions? Any questions and doubts you are having?
Till now, no, that, sir.
You have taken the screenshots properly?
Yes, sir. I have taken.
Okay, very good.
Yes, sir.
Okay, Gajanan, come in.
Yes, sir.
Understood the concepts properly?
Yes, sir. Yes, sir. Understood. I have taken, sir, screenshot.
Screenshots. Anything missing? Anything you want? The screenshots? Anything?
No,
Any
sir.
screenshots you have missed? Any session
Not
you have
missing, sir.
missed?
Sir,
No,
I am
right?
No, sir. No.
Okay, good. Yes, Rachna, tell me.
sir, I missed the first session actually.
First session. Okay, so just let me load the project. Just hold on. Okay, so just hold on. This is your first project. Okay, this is the first session. Simply take the screenshot.
Yeah, tomorrow is our last class for
Yes,
networking.
that is correct. Rachana, is it done?
Yeah, this done, sir.
Okay, then take this particular screenshot over here.
Okay, done.
Take this part.
Yeah. Okay.
Taken. Then take this part.
Yeah, taken.
And this is the last session. Okay, after that you have taken the OSI, right? Open system interconnection, all this is you have taken, correct?
OSI model, I have taken only 7 layers definitions screenshot, but I didn't took that is TCP, UDP protocol.
Okay. Just hold on. This is your layer 4.
Yeah. Okay.
Taken.
Yes.
Then this is the part.
Yeah.
Finished? Okay, everyone. So that will be it. I will see you guys in the next session. Okay. Bye for now and take care, everyone.
Thank you, sir.
Thank you.
Same to you.
Thank you, sir.
Thank you, sir.
All of you, bye. Bye.
Recording stopped.